Hi students, today we'll continue with the organic chemistry of class 10. We have started this lecture of organic chemistry in the previous video, and we have ended up that video till the IUPAC nomenclature. Though we haven't completed that IUPAC nomenclature, so we'll be starting that from the IUPAC nomenclature and we'll finish the full organic chemistry today. I'll be giving the link of the previous video in the description box. Please watch that so you'll be able to understand properly. So if you go through this video, the previous one and this one, then your ICSE examination will be very good. All the questions will be coming from these portions. Okay, so let us go through this. So organic chemistry, the next portion will be starting with the IUPAC nomenclature. So I'll not write all the rules and regulations of the IUPAC nomenclature. I'll give some examples and according to that we'll start that. Okay, so let us start this one. So suppose, how will you name an organic compound? So already in the previous video I told you that depends on the number of carbon and what type of bond is present in that. Preliminary depends on that. Okay, so that is the first thing. And next, to understand the full IUPAC nomenclature, we have to learn some terms here. So we have learned about alkane, right? Alkanes are these all: methane, ethane. These are alkanes, we all know, right? Now if an alkane removes one hydrogen atom from its one of the bond, removes one hydrogen atom. This carbon has 4 bonds, we know, because this is the structure of the methane. If one of the hydrogen is not there in the methane, then it will look like this. Okay, similarly, if one of the hydrogen is not there, then it will be C2H5. Similarly, if one of the hydrogen is not there, it will be C3H7. When an alkane removes one hydrogen from its structure, it calls alkyl group. So these all are the examples of alkyl group. This is very important to know, to understand and to write for the IUPAC nomenclature. If you don't understand this portion, they will be unable to understand the IUPAC nomenclature, unable to write the IUPAC name. Okay, so these are the alkyl groups. So how to know the alkyl groups? When an alkane can be abbreviated like this, RH. If it removes one hydrogen, it will be forming bond R. It is called an alkyl group. These all are alkyl group. Now how to name an alkyl group? From the alkane, we'll add with YL. Suppose this is methane, we know. This is methane. Why methane? Because one carbon means meth and single bond means N. One carbon means meth, single bond means N. So it is methane. If methane removes one hydrogen, it will form methyl. So this CH3 is called methyl group. CH3 is called methyl group. Similarly, this C2H5 is called ethyl group. And this C3H7 is called propyl group. So how to know about the alkyl group? When alkyl removes one hydrogen, it forms alkyl group. Ethyl, methyl, propyl. These names are very important if you want to write the IUPAC nomenclature. Okay, it's very simple. Next is that, okay, these are the groups. Now apart from these groups, we have some other groups also. Those groups, if those groups are present in the organic compound, it totally changes the property and the nature of the organic compound. Okay, there are some specific groups are there having different number of atoms. It can be having oxygen, hydrogen, it can be with carbon, hydrogen, oxygen, it can be with oxygen, oxygen, carbon, hydrogen, like that. If those groups are present in the organic compound, that internally changes the property and the nature of the organic compound, and we get a new type of compound. Those are called functional groups. So these are normal groups, and the groups I'll tell you now, those are the functional groups. So what are the functional groups? Functional groups are This definition is very important. It can come in the MCQ also, or in the fill in the blanks in ICSE examination. Okay, ICSE chemistry examination. So functional groups are these. OH. This is one of the functional group. Okay, this is called hydroxyl functional group. Okay, O bond H. This is called hydroxyl functional group. Now, if this hydroxyl functional group is present in an organic compound, suppose it is present in an alkane or alkene or alkyne, then those will be called as alcohol. So this OH, if it is present in a compound, it will be alcohol. So that is why sometimes it can be called as alcoholic functional group. Okay, suppose I'm giving you example. Suppose you have methane, right? You have methane, this one. Now if you remove this hydrogen, okay, and attach this OH here, now the compound you have got, it has an alcoholic nature, so it is alcohol. Okay, so what is the formula of the compound? You can write like this: CH3OH. This compound has a common name. Now how to write the common name? We'll go for the IUPAC nomenclature later on. First of all, let us do this. Okay, CH3OH. This CH3 is methyl. Already we have learnt, now only methyl, and anything which has OH, the name will end with alcohol. So it is methyl alcohol. This is common name. Apart from the IUPAC nomenclature, we need to know this, because sometimes examiner ask you what is the formula of methyl alcohol. So if you do not know, then the problem will be there. So this is methyl alcohol. Similarly, if you have C2H5 group, already you all know this is ethyl group. We have learned now only ethyl group. If ethyl group is attached with OH, it will be ethyl alcohol. For all the class 10 students, the common name of these two compounds are very important. You should know that which one is methyl alcohol, which one is ethyl alcohol. CH3OH is methyl alcohol and C2H5OH is ethyl alcohol, right? Now this C2H5OH can be written like this: CH3 CH2OH. This is also ethyl alcohol, same. Okay, we have learned the condensed formula in the previous video, so those who have seen that video, they can understand this is CH3 CH2OH, ethyl alcohol. This one is also ethyl alcohol, this one is also ethyl alcohol. Okay, now let us go for, again the examiner can ask you write to state two formula of the compounds having alcoholic functional group or having OH group. So you can give this CH2OH, C2H5OH. Okay, so this is alcoholic functional group. Okay, now again this is another one functional group. This is COOH. Okay, this is called carboxylic functional group. Or sometimes it can be called a carboxylic acid group. Carboxylic acid. Okay, the structure of the carboxylic acid is this: COOH. One oxygen out of two will be attached with carbon in double bond. The other one will be with the single bond with carbon and hydrogen. So this is C double bond OH. Okay, this is carboxylic acid group, right? Now the carboxylic acid groups are present in a compound, it will be carboxylic acid. And all the carboxylic acids which are organic, they are weak acids. Suppose you have taken one alkyl group CH3 and with that COOH. Obviously it has a IUPAC name, we'll learn it later on. This one is acetic acid. Okay, so one example of a compound having COOH is acetic acid. Again, all these organic acids are weak acid. This is also weak acid. dissociates partially in aqueous solution. Similarly, formic acid, these are the common name. Okay, common name, formic acid. I think it's clear. Now these two are there in the syllabus. Okay, we will learn apart from the syllabus little bit, but I'll tell you about the scope of the syllabus of the ICSE. Okay, exactly the scope of the syllabus. OH group is there, CWH is also there. Okay, let us go for another one. We have this functional group. This is called carbonyl group. Okay, this C double bond O is called carbonyl group. Now this group has two functional group. If with the C double bond O, if you can see, this is carbonyl carbon, this carbon is called carbonyl carbon. Okay, now with this carbonyl carbon, if one directly attached hydrogen is present, at least one directly attached hydrogen, then it will be aldehyde. So this one, C double bond OH, this is called aldehyde. Okay, now if this central carbon is attached to a 2R group, R means alkyl group, it can be CH3, it can be C2H5, it can be anything. Okay, it will be called as ketone. So this one is ketone, this one is aldehyde, this one is ketone. I think it's clear to all, everybody. So this one is aldehyde, this one is ketone. Ketone is not there in our syllabus, but we have to learn. This aldehyde is there. Now we have learned the structural formula of aldehyde. This is the structural formula, SF. Okay, you have to know the condensed formula also. CHO is the condensed formula of the aldehyde. Okay, CHO is the condensed formula. Structural formula is C double bond OH. Okay, now this aldehyde, we can take some example of the aldehyde compound, right, as a common name. CH3CHO, this is called acetaldehyde. This is example. HCHO, this is called formaldehyde. You can relate the names, right? You can relate formaldehyde, formic acid, acetaldehyde, acetic acid. Okay, this is there in the syllabus. So in our syllabus in ICSE, we have this group, and this one. These three we have. Okay, now apart from this, I'll tell you some more, but those are not there. IUPAC nomenclature, it will not come with that. Okay, will be coming only in this functional group, IUPAC nomenclature. Now let us take example for the ketone. For this ketone, CH3COCH3, this is a good ketone. This is called acetone. Okay, remember this. This is called acetone, an important organic compound. It is mostly used in the organic synthesis. Acetone. Okay. Now let us go for other functional groups. So we have learned this, right? OH, COOH, CHO, C double bond ORR, right? We have another one, COOR. This is called ester. Okay, this functional group is called ester. We have to know this because we have the esterification reaction. So to understand this, we have to know this ester. Suppose this will be an alkyl group, like CH3 can be there, and if you put CH3 here, this can be an ester, CH3COCH3, CH3COOCH3. Okay, now how to name this? This ester, if you split this, you will get two parts here, CH3COO and CH3. Now this CH3COO comes from acetic acid, right? What is the formula of acetic acid? CH3COOH. This is the formula of acetic acid. Am I right? Now when it dissociates, it forms acetate ion. This is called acetate ion. Now this acetate ion is this one with this methyl. So this is acetate and this is methyl. So what will be the name of the compound? It will be methyl acetate. Methyl acetate. Now these esters has a characteristic smell. They have a fruity smell. Like acetic acid smells as vinegar, it also smells as a fruity smell. Okay, so methyl acetate. Similarly, if you write this, suppose you have written this CH3COOC2H5. So if you split this from here, the C2H5 is ethyl and this one is acetate. So what will be the name? It will be ethyl acetate, right? It will be ethyl acetate. Yeah, it will be ethyl acetate. So these are the functional groups which are there. Apart from this, we have more from here. We have this functional group also, oxygen at the center, and in the two side, two bonds are there. This is called ether. Okay, we have some examples. This one, CH3. This must be attached to the alkyl group, right? It is called dimethyl ether. Dimethyl ether. Similarly, it can be diethyl ether also. Okay, in class 10 syllabus, we don't have the IUPAC nomenclature and detailed treatment of the ethers. But this is again in a functional group. We have this also, CONH2. This is called amide. NH2 also there. This is called amine. Okay, we have many, but in ICSE we have these three. Okay, so we have learned the terms of the IUPAC nomenclature. Now let us go for the IUPAC nomenclature. I think these parts we know. The IUPAC nomenclature normally depends on the number of carbons and what type of bond is present. Okay, and before we write the IUPAC naming, we have to know the sequence, how to write. First of all, we will write the prefix. Then we will go for the word root. Okay, then we will go for the primary suffix. Then we will write the secondary suffix. Okay, now the prefix are alkyl groups like these CH3, C2H5, C3H7. These are the prefix, etc. Methyl, this is methyl, you know, ethyl. Their names must be written in front. Okay, these word roots are the number of carbons, like one carbon meth, right? This is meth, eth, prop, like that. The primary suffix are the in, and ein. Means if it is single bond, then it will be in. If it is double bond, then it will be in. If it is triple bond, then it will be ein. It will end with ein. And the secondary suffix are the functional groups. Okay, these are the. Now, if a carbon chain is given, the first rule is that find out the longest carbon chain. Suppose a compound is given like this: CH3, CH2, CH2, CH3, CH2, 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 CH3. Okay, you have to find out a chain which has large number of or greater number of carbons. Okay, you have to number the carbons from any one of the end, any one end, like from this end or from that end, 1 2 3 4, like that. So suppose I start numbering from here, 1 2 3 4, I go like this. So in a chain, how many carbons are there? In a chain here, how many carbons are present? 4. In this chain, 4 carbons. But if somebody goes like this, 1 2 3 4 5 6 7, if they go like this, in this chain, how many carbons are present? 7 carbons. So according to the rule, this is the correct numbering. Okay, so first rule is that find out the longest carbon chain. This is the longest carbon chain, right? 1 2 3 4 5 6 7. This is wrong, this is right. Okay, so this is how you can find out the longest carbon chain. Next is that you have to number the carbons in such a way, if the carbon contains double bond, is attached with double bond or triple bond or any functional group, that should get less number or least number. Okay, in class 10 we do not have much critical problems, we will not get much critical problems, but we have to learn. Okay, so let us start one by one. If I tell you all the rules together, then there will be confusion. So let us start. Suppose you're writing this one, CH3 CH3, and in branch we have the CH3. Now the rule is that you have to number the carbons from any one of the end, 1 to 3. Okay, now second is that you have to mention the number of the carbon which has the prefix or functional group or double bond or triple bond. Now here we have on number 2 carbon we have CH3. On number 2 carbon we have CH3. This CH3 is named as methyl. Okay, so this one is the prefix. This one is the prefix. This goes in the prefix. And in a chain we have 3 carbon. We have 3 carbon. So 3 carbon means prop. We already know this. 1 carbon eth, 2 carbon meth, 1 carbon meth, 2 carbon eth, 3 prop, right? 4 means but, 5 means pent, like this we all know. So 3 carbon prop. And what type of bond is present? Single bond. We know that N means single bond, in means double bond, and ein means triple bond. So one bond is there. So prop is comes in the word root. What type of bond is present? Now we are going for the primary suffix. We have written the prefix. We have found the prefix here. CH3 is the prefix, methyl. Then word root is the prop, and single bond is the in. Propane. Now we have to again mention the position of the single bond. Now you can see from after number 1 carbon, you have to see from any one of the end, like from that way or from here. Now as you have numbered this carbon as 1, so after 1 carbon you have a single bond, right? After 1 carbon you have a single bond. So here the position of the single bond, that means position of the in, is after number 1 carbon. Okay, so the prop in, but here the position of in is after number 1 carbon. So it should be prop 1 in. Prop 1 in. Now you will ask me, sir, why you have given this hyphen? The rule of the IUPAC nomenclature is that after a number, before writing a word, you have to give a hyphen. After a word, before writing a number, you have to give a hyphen. Okay, this is the rule. So that is why I've just mentioned the position of the single bond, first single bond. We know that after second carbon also single bond is there, but you have to mention only one position. So here after one carbon, one N, this one. So if you join this all, if you write, this is nothing but first of all the prefix. Okay, do not forget this prefix, then the word root, then primary suffix, then secondary suffix. So prefix here, methyl. This is the methyl prefix. What is the position of this carbon? Number 2 carbon. So at the number 2 carbon, methyl group is attached. So it is 2 methyl. Now again this writing is wrong because we have not given a hyphen. 2 is the number of the methyl group. 2 is the position of the methyl group. Okay, at which the methyl group is attached. 2 methyl. Now the word root. 2 methyl. Now this one is a word. After writing a word, if you want to write another word, you don't have to give any hyphen. So 2 methyl. Now how to write? Prop. 2 methyl prop 1 in. Why 1 in? After number 1 carbon you have a single bond. Now combinedly you can join this. This prop 1 in. 1 in you don't have to mention every time because 1 is we can consider. Okay. If it is 2 or 3 then it is you have to write, but 1 we can consider. So basically it is nothing but 2 methyl propane. This is nothing but 2 methyl propane. Now in ICSE, this the main IUPAC nomenclature rule is that when you finish a naming, when you end a naming, all the words should be together. 2 methyl propane should be together. There should not be any space, but it can be considered. 2 methyl propane, it should be together. As I said, 2 methyl propane should be together because there is no number and it is the end word. But again, if you write like this, it can be considered in ICSE. Okay, 2 methyl propane. Now let me see, you can write this one also. No, not. This is, suppose you have written this CH3, CH2, CH, Cl, CH2, CH3. So you have to number the carbon from any one of the end, right? 1, 2, 3, 4, 5. You have to number the carbon in such a way the carbon which bears the. Achha, let me tell you this. What is this Cl? This Cl is chloro. Okay, Cl is chloro. Br is bromo. I is iodo. F is fluoro. Okay, so these can be also considered as prefix. You have to write these names before as a prefix. Okay, so what is the number of the position of the chlorine? Chloro is third position. You have to number the carbon in such a way that this should get least number. Now I have numbered from this end 1, 2, 3, 4, 5. You can number from this end also. It will be same. See, 1, 2, 3, 4, 5. So 5 carbons you are getting, and on number third carbon you have chlorine. Okay, so for this one is same thing. If you number from this side or that side, both the things are same. So here it will be 3 chloro pentane. Why pentane? Because 5 carbons are there. Okay, 3 chloro pentane. Now if it is written like this, see all these forms I am writing in a condensed form, not in the structural form, right? So if somebody numbers from here, will it be correct? No. Why? Because here the number 4th carbon, number 4 carbon has the methyl. The rule is that you have to number in such a way the carbon that has the methyl or any group that should get the least number. So this should be the correct naming. 1, 2, 3, 4, 5. Not this. Number 2 carbon has methyl. So it will be 2 methyl pentane. 2-methyl pentane. This video is already for 30 minutes. Okay, let me see how far I can reach, or I have to make another one video. Okay, so this one is 2-methyl pentane. Now let us go for adding some double bond or triple bond. Suppose this one is given CH3CH to CH double bond CH2. You have to number the carbon in such a way the carbon that bears the double bond or triple bond, that should get the least number. So if you want, you have to number from this end. This should be number 1 carbon because this has the double bond. 1, 2, 3, 4. Now there is no prefix here. There is no chloro, bromo, there is no methyl, ethyl, right? Now don't take this CH3 as methyl because you have to choose the longest carbon chain. You have to choose the longest carbon chain. So it is coming in a carbon chain only. Okay. How many carbons here? 4 carbons. So bute. Now another one thing, if any compound has double bond, the compound is alkene. Is a double bonded compound. Yes, it can have the single bond also, but we will not consider the name of the single bond. We will only consider the name of the double bond. So here 4 carbons are there. Bute. Now we will see the position of the double bond. Okay, we have started numbering from this end. So it should be number 1 carbon, then the double bond. So after number 1 carbon, you have a double bond. Don't consider this 2 because you are not seeing from that part. Okay, we have numbered from this part 1, 2, 3, 4. So bute is, why bute? Because 4 carbons are there. Then bute hyphen 1 in. Why 1 in? After number 1 carbon, you have a double bond. Double bond means in. Why this hyphen? Because you already know that before writing a word and after a number, you have to give a hyphen. Bute 1 in. If you combine this, you can write like this: 1 butene. 1 butene is nothing but butene. Okay, all these names are correct. Now suppose if I change the position of the double bond, if I change the position of the double bond, CH3 CH double bond CH3, you can number from any one of the end. You can number from this end or that end. Okay, so how many carbons are here? 4 carbons are here. 4 carbon means bute. 4 carbon means bute, and after second carbon you have in, so it is 2 butene. Now 2 butene cannot be eaten as butene. Butene is 1 butene, 2 butene is 2 butene. Different thing. Okay, so this is another one part. Now let us go for some more examples. Let us consider triple bond. Now suppose this is given. Again same rule as we have done for the double bond. 1, 2, 3, 4. 4 carbons, bute. After 1 carbon you have ine. Triple bond means ine. Let me tell you, this one is word root, this one is the primary suffix. We have not considered yet the secondary suffix, right? So this is bute 1 in. Bute 1 in means 1 butene. Sorry, 1 butane. 1 butane or butane. If I change the position, like this, it is 3 hexane. Why 3 hexane? Hex 1, 2, 3, 4, 5, 6. 6 carbons are there. After third carbon you have hex, ine. Ine means triple bond. Hex means 6 carbons, so 3 hexane, right? Now let us approach with the functional groups. Now the functional groups are like this. Suppose you have this. Already we know the common name of this compound. This is ethyl alcohol, right? but we haven't learned the IUPAC name. Let me tell you, if OH is present in a compound, it will end with all. For IUPAC nomenclature, it will end with all. If CHO is there, it will end with L. If CHH is there, it will end with oic acid. And if C double bond OR is there, it will end with on. Now these three are there in the syllabus. Okay. Now the carbon that has the OH group, that should numbered with the least number. So that should be 1. It should be 1. It is the rule. The carbon which bears a double bond, triple bond or functional group, it should get the least number 1. So it is, how many carbons are there? 2 carbon. So eth, you have a single bond, ethane. Okay, and after number 1 carbon we have all. So ethane 1 all. Ethane 1 all. If you combine this, it will be ethanol. Right? This is ethanol. So ethanol is CH3CH2OH and it is nothing but ethyl alcohol. Ethyl alcohol the common name, ethanol is the IUPAC name. Okay. This one, you have already understood the numbering of the carbon. 1, 2, 3, 4. 4 carbons are there. Butane. Butane. Why butane? 4 carbons, but, single bond N, butane. Now on 2 carbon, number 2 carbon, you have OH. So 2 all. If you combine this, 2 butanol. 2 butanol. Sometimes students do mistakes on this. They write hydroxy here. Like 2 hydroxy like that. You cannot write here. There is some specific conditions are there for which we do this hydroxy and all, but not here. It will be 2 butanol. Okay. Let us consider some aldehyde groups. Suppose this is given CH3CHO. This is number 1 carbon, number 2 carbon. How many carbons are there? 2 carbons. So ethan, right? And this CHO means L. CHO means L. So it is nothing but ethanol. CH3CHO is ethanol. HCHO, it is methanol. They can give you this kind of thing. Suppose this is given mixed, a CHO group and a chloro. So you have to number from this end, right? 1, 2, 3, 4. This can be a prefix. 2 chloro. 2 chloro. How many carbons? 4 carbons. Butan L. 2 chlorobutanol. Okay, 2 chlorobutanol. Why L at the end? Because CHO group is there. Don't forget to give hyphen here. Because IUPAC nomenclature is very important. If you do little bit mistakes here, you will be deducted marks. Okay, so see this hyphen. Now suppose this is given, consider a CHH group. How many carbons? Now here you have to consider the CHH carbon also. For CHO also you have to consider the carbon that is there in the CHO. So this carbon must be taken into the consideration. 1, 2, 3. Okay, how many carbons? 3 carbons. Propan, and on 1 carbon you have oic acid. CHH means what? Oic acid. So if you combine this, you will be getting propanoic acid. Okay, you have to consider the CHH carbon. Okay, next is that this one. 1, 2, 3, 4. This is nothing but butanoic acid. Okay, now the examiners can give you combine. In ICSE they give, sometimes they give you one double bond, one prefix, chlorobrom, methyl, a functional group with methyl, a double bond with a functional group, like that they give you. Okay, so today we are going to end the video here only. We'll be starting the next portion, that means isomerism and the reaction part, with the next video. Okay, I'll be giving the previous one link in this video in the description box. Please watch that, and if you have any doubt here, you can readily write on the comment box. I'll do reply. And before the 11th of March, I'm going to cover all the chapters. Okay, so if you have anything to know related with this, you can comment me on the comment box. Thank you for watching.